Hi guys, so this is going to be our last set of notes over fingerprinting. There are quite a few slides on this. You should have already picked up the PowerPoint packet. Just make sure that you are underlining, highlighting, and writing out any extra information that's given. You guys are going to have a test in about a week, maybe a week and a half. I will give you the exact date when I come back. And this is going to go through pretty quickly, so you need to be following along. So here we go. So fingerprints follow three fundamental principles that we always are able to utilize them in forensics or in criminal type investigations. And you are going to be responsible for all three of these. So you need to be able to know what they are and to be able to explain them. The first thing is the fact that it is a unique or individual characteristic, which means that no two people have the same fingerprint, even if they're like twins, identical twins or whatever. So this is going to make fingerprint evidence individual evidence. So know that it's an individual characteristic, and because it's an individual or unique characteristic, it is individual evidence. A fingerprint pattern also pretty much stays the same. It remains unchanged for the life of the individual. Now the pattern itself is always going to be whatever it started off as. Whatever you originally have, that's what you're always going to have. However, the pattern can get adjusted, like the print itself can get adjusted if you have scars or damage or some kind of disease that will either like cover up your prints or will make changes to your prints. So your pattern doesn't ever change. That's controlled by your skin. But we can alter what the print itself looks like if you have other things happening to your fingertips. Okay, the last fundamental is that fingerprints have general characteristics based on ridge patterns. So if you look at those individual lines within your fingertip, that's what's going to make up the print. And because there's all these different characteristics or traits, it allows us to systematically identify that print. So it's not just, oh, you have an arch and you have an arch, so obviously you're the same person. It's more about looking at the fine details within your fingerprint to determine if this print actually matches this person. So as we've mentioned before, there are three different groups or categories to fingerprints. They all fall into either arches, loops, or whorls, and each group is divided into subgroups or smaller groups that we've listed out below. So you can have two kinds of arches, either a plain arch or a tented arch. You can have a radial loop or an ulnar loop, and then if you have whorls, you can have a plain whorl, a central pocket whorl, a double loop whorl, or an accidental whorl. And we'll go through and give examples and pictures for all of these in a second. If we broke down the population, like the world's population, we looked at just their fingerprints or their finger patterns, we'd realize that 60% of all people have loops, about 35% have whorls, and about 5% have arches. And sometimes the number fluctuates for the loops and the whorls. Sometimes it's 65% of people have loops or 30% of people have whorls. It just depends on the population, and like how many individuals they've actually looked at. Another name for fingerprint identification is dactyloscopy. So another name for a fingerprint is a dactylogram. So this is a little interesting fact. But know that sometimes we do refer to fingerprints as dactylograms. So we're going to step through the three groups, and we're going to talk about all the subgroups, and we're going to give you images to go with how to identify which is which. So starting with arches. The arch is going to be the simplest of the fingerprint patterns. Like there's just not a lot going on an arch pattern. The way you can always tell that you're looking at an arch is that the ridges enter on one side of the print, they will rise up in the middle, and then they'll exit on the other side. The other thing that you're looking for with arches is they don't have a triangular pattern called a delta. So I'll show you what that means in a little bit. So if you follow my pen, remember each of these little black lines represents the ridge. So these ridges come in this way, they go up in the middle, they go out that way. These ridges do the same thing. They come in this way, they go up in the middle, they go out that way. Now the difference between the two kinds of arches has to deal with how much of a point the top part of the arch comes to. So I'm going to erase this real quick. On a plain arch, it's a very rounded top. So again, we come in, oops, sorry. Okay, so we come in, we go up, and we go out. Very rounded top. It almost looks like the top of a hill. Whereas on a tented arch, it comes to a point, or it's more pointy in the middle of the arch pattern. So we come in, we go up, we come out. Okay, so that's what you're looking for. Is it more rounded in the middle, or is it more pointed? And that tells you if it's a plain arch or not. Another thing that tented arches have is they have this spike in the middle. So I'm going to try and draw it in for you right here. That would be the spike in the middle. Okay, and notice that your plain arch does not have that feature. Another interesting thing about arches is we know it's the least common type. Only about 5% of people have this, and it's most likely or more likely to be found in people of African ancestry. Loops are the next category. So loops always have at least one delta. So really quick, let me show you what the delta looks like. If you look at the middle of the page, this little triangular piece right here, that's your delta. So on this picture, I've circled it for you right here. I did not circle it on this picture, but I will go ahead and do so now. So right there, those two spots, that's where your delta is. Loops always have one delta, and their ridges enter and leave the print on the same side. So I'm gonna draw that in so you can see. I think, yeah, I'll just do it in red again. So over here you can tell that the loops come in, they go around, and they go out. We enter and exit on the same side of the print. On this side, we go in, we go around, we come out. They enter and exit on the same side of the print. So there are two kinds of loops. There are ulnar loops and there are radial loops, and they are named for your arm bones that they point to. So you have two bones in your forearm, the ulnar bone and the radial bone, and these loops are named based on where they open. If they open towards the ulnar bone, they're called ulnar loops. If they open towards the radial bone, they are called radial loops. So ulnar loops open towards the right of your print, or another way to think of it is that they open in the same direction that your pinky is, so they open towards your pinky, or they open towards the ulnar bone. Radial loops open towards the left, or towards the thumb, or towards the radial bone. So that's kind of one of the ways that we tell the difference between the two. This is going to be your most common type of pattern. Anywhere between 60 and 65% of people have loop patterns, and it's more common in people of European ancestry or European background. The last grouping are whorls, and whorls have the most subgroups, or the most smaller sections within it. So whorls have at least one ridge that makes or tends to make a complete circuit, like a complete circle. They also have at least two deltas, and the deltas are normally found on either side of the whorl pattern or the circuit pattern. So if you look at the image here, we have a delta here, we have another delta here, then there's one delta just about here, the other delta is just about there. So they always have two. And notice that they go around in a circle. So the first two subgroups are the plain whorl and the central pocket whorl. The way I always think of it is the plain whorl looks like a bullseye to me. It looks like I have a circle, and then I have another circle around that, another circle around that, another circle around that. Whereas the central pocket whorl looks more like a spiral. So I start off with this opening, and then I spiral around. Okay, so that's one of the ways I tell the difference. Now, it's not always easy to see that right off the bat. The more fingerprints you look at, the better you become at telling the difference between all of these different kinds. So another trick is to use the deltas. Excuse me. On a plain whorl, you will find your two deltas. You would draw a line that connects the two deltas, and if the ridges touch the line, so if those circular patterns go around the line, then it is a plain whorl. But if the patterns sit above the line, so they don't touch the line, then it's a central pocket. And central pockets always have like a center core, like they have an opening right there. The other two groupings of whorls are the double loop whorl and the accidental or mixed whorl. So starting with the double loop whorl. Double loop whorls literally are two loops that have like wrapped themselves around each other. To me, it looks kind of like the yin-yang sign. So I'm going to draw out in two different colors to show you where these would be. So on this diagram here to the left, you have one whorl that goes this way. And then on this the same diagram, the other whorl goes that way. Okay, so you have these two loop patterns, but they're all twisted together. With the accidental whorl, it's what happens when you have multiple patterns in one print. So you might have two or more patterns that make up this one print. Really, this is we're not super sure if you're a loop. We're not super sure if you're an arch. You kind of look like you can be all of it. So we're going to put you in this grouping and call you an accidental whorl. So whorls are found in about 30 to 35% of the population, and it's most common among people who have Asian ancestry or Asian background. So I mentioned before that within your fingerprint pattern, we have all of these little tiny little features or characteristics that we're going to use to analyze your print. This is the entire list of those characteristics. They're called ridge characteristics, or sometimes they're called ridge minutiae, and there's several of them. A lot of it is kind of, I don't really want to say common sense, but a lot of them, they kind of match up with their names. Now, there are a few that are weird, like bifurcation just means that you have two lines meeting together. Okay, I'm not going to take a lot of time on today's video to go through and explain this, but the assignment that you will work on at the end of the video you do need to use this particular slide of your PowerPoint to help you figure that out. On this image, we've taken a section of a print and we've blown it up a little bit so that you can see some of the features. Now, just in this little general area, there are a bunch of features. There are like 10 of these that are labeled. So it just goes to show that within every pattern, there are lots of these little characteristics that will help to make that print more and more individual. And I can see right off the bat that there are a few here that haven't been labeled. Like, for example, right here, whoops, sorry, my bad. Let me change to my pen. So right here, we have a hook. Like that one wasn't labeled. I mean, all of them won't be labeled. But it just, again, goes to show that there are all these different features. So when we're looking at a print, this is literally what we're looking for. This person has a bifurcation right on this spot. Okay, so I'm gonna take my crime scene print and see if that print also has a bifurcation right at that spot. There is a dot right at this spot. Does that crime scene print have a dot right at that spot? That's what the comparison actually is. And that's why it took so very long before it was all done on computer, because you had all of these things that you were looking for. So in terms of comparison, fingerprints it's all based on how they're similar. So we don't really pay too much attention to the differences, but we do pay attention to where are they similar? What do you have in common? Where are those features found on the print? Now, there is no legal requirement in the US on the number of points that have to be similar for it to stand up in court. So generally speaking, they accept anywhere between 8 to 12 points of similarity. So there's no law that says the print must match up in these 8 different spots, or the print must match up in these 5 different spots. We just generally say, yeah, anywhere between 8 and 12 is fine. So in terms of collecting and classifying prints, there are a couple of ways we can do it. We can take actual prints of the person if we have access to their hand, and those are called rolled ink prints. And again, we're just looking for those 3 characteristics. We're looking for, or patterns, sorry, the loops, the whorls, the arches. And then we're going to look at the minutiae to see if there are any similarities there. And then we give it a primary identification number, which is based on the Henry classification system that we learned earlier. We can also lift prints from the scene of a crime, and we do that by either developing the print with some kind of powder or with some kind of chemical, and we'll step through all of these in the upcoming slides. And then there are other things on your body that leave prints behind. So your palm, your teeth, your lips, your eyes, your ears, even your voice has a specific print. Of course, there are things like shoe prints and footprints as well. And within the rest of the year, we'll look into some of these. So now let's talk about types of fingerprints. There are three main types of fingerprints, starting with the patent print. Now, just be aware, a lot of these are going to sound similar, okay? So it's important that you realize what the differences are. So the first kind of fingerprint are patent prints. Patent prints are visible prints that are normally left on some kind of a smooth surface. So your hand has blood or ink or chalk or paint or any kind of colored material on it. You touch a wall or a desk or a table, you leave a print behind. That's a patent print. It's an obviously visible print. I walk into the room and right away I can tell this person touched the wall. They touched the door. Okay, patent prints are followed by plastic prints. And plastic prints are very different. They're 3D indentations, and they're normally left in some kind of soft material. So you picked up a bar of soap that was slightly wet at the bottom or at the top, and you pushed your fingerprint into that bar of soap. So think things like clay, wax, even dust can hold these prints. The last grouping of prints are called latent prints, and latent prints are hidden prints. They're the ones that you leave every single day, but you're not aware that you're leaving them because you can't actually see them with your naked eye. And they're caused by the transfer of oils and other body secretions from your finger onto whatever surface it is you've touched. These are the prints that we have to make visible. So they're not already visible for us. We have to kind of dust for those prints or lift those prints with some kind of chemical. So if you are a fan of any of the crime shows, you sometimes see them dusting with those fluffy brushes, like around doorknobs and windows and that kind of thing. What they're trying to do is to see if any latent prints have been left behind. So let's talk about where the stuff that makes up these prints come from. The secretions come from glands within your body, and there are three major kinds, and they all secrete something slightly different. So they're eccrine glands, which secrete mostly water and organic and inorganic salts. These are going to make up, these types of secretions, make up the bulk of your fingerprints. We also have apocrine or apocrine glands, and they secrete pheromones and other organic materials. Pheromones are like chemical signals. And then we have sebaceous glands, which secrete fatty or greasy substances. So think more oil. Now we're going to step through the process of how we develop latent prints. So because these prints are invisible and we have to make them visible, the first thing we want to do is we're going to choose a method that allows the print to stand out from the background that it's in. So you tend to choose either powder or you're going to use a chemical. Which you use depends on the surface that the print has been left on. Now, sometimes we'll use multiple techniques on the same print, but we have to be really careful because some of the chemicals especially can destroy parts of the print. And if we use that chemical, if we don't get the print imaged at that point, the print is no longer useful because the chemical has deteriorated certain things within the fingerprint that we would need. So the first and mostly the go-to method is to dust. And when we dust, we're going to use powders to do that. So we lightly apply a powder to a non-absorbent surface, and we do it with a very soft brush. We have these fluffy brushes, just like the ones that they're showing you in this image. We also have some thicker, smaller brushes, but they're more for patting powders on. And then we also have magnetic wand brushes, and you'll get to use all three of these later on when we start labs. The reason we use powders is because the powders stick or adhere to the sweat, which is mostly water, residues left behind in the print. They'll also stick onto some of the oils left behind from the print. So there are three main kinds of fingerprint powders, and it really has to do with what's the color of the background and also what type of material the print was left on. That will determine which of these three we would use. So the most common used are gray and black powders, and it's because they give you the most contrast with multiple surfaces. So especially if the surface is light in color, or sometimes even if it's a bright color, that black will pop off of that background color and you'll easily be able to see the print. Now in my classroom, that won't work so well, especially on our lab tables, because our lab tables happen to be black. So in that case, we would use a gray or a white powder instead to develop that print, or to bring that print to the foreground. We also have magnetic powders, and we use special magnetic wands to apply those powders, and those work better on rough surfaces, especially like plastic and leather. Then the last grouping of powders would be fluorescent powders. And we especially use those when we need to photograph a latent print, and if that print is on a multicolored surface. So the fluorescent powder, when we take the picture, it'll show off different colors in the picture based on the background. Like when we look at them under UV light, we'll be able to see it a little bit better. Okay, so now let's jump into the chemicals that we would use to develop fingerprints. The first chemical is called Nenhydrin. Nenhydrin specifically reacts with amino acids or proteins in our sweat, and when it does that, it produces a blue, kind of purplish background, as you can see right here on this picture. So we put it in a solution of ethanol, we put it in a bottle, and we spray the surface lightly. We kind of let it dry off, and you'll get this purple color wherever there was actually a fingerprint. This is really useful on surfaces that are absorptive or porous, so paper, cloth, tissue, that kind of thing. Okay, another chemical that we can use is something called physical developer. Physical developer is a silver nitrate based reagent, and it is liquid. And again, we can use it on porous surfaces, so paper, tissue, drywall, that kind of thing. It is normally the very last chemical that we would use because the silver nitrate destroys the proteins left behind in the fingerprint. This particular solution is going to turn your print gray when it's exposed to light, but it will break the print down, so we only really use physical developer if nothing else is working. One of my personal favorites is cyanoacrylate, also known as superglue fuming, and we can use this on a variety of different types of materials. And we also use them to, not just to develop the print, but we can also use it to like attach it or fix it to a different surface. So we literally just use like super glue, like crazy glue. You put a little bit of crazy glue in a container that can withstand some heat. You put your object that has your print in it. You turn the heat up, and the heat is going to turn the super glue into a gas. And as that gas moves through the air, when it comes into contact with the print, it is going to form a hard white deposit with the water inside of your print. And then you can just peel that deposit off, and you'll have your fingerprint in hand. So in recent times, we've had some newer chemicals come on the market that have become a good, or a better way, I should say, than to like develop prints than some of the chemicals we've had in the past. So for example, Nenhydrin is a very popular chemical that we use in forensics, but we now have a better version of that, and that's called DFO. So the reason it's better, quote unquote, is because it's more sensitive than Nenhydrin. So it will react with smaller amounts of proteins, whereas Nenhydrin will require larger amounts of proteins. Then another one that can replace superglue fuming is rhodamine 6G, and this is a fluorescent dye that we can use. I'm sorry, it doesn't actually replace superglue fuming. It's used after superglue fuming. I apologize. So we superglue fume the print. We pull the print off. That print is going to be white and kind of, hard. And then we treat it with this rhodamine 6G, which is a fluorescent dye. And when we stick that print under UV light, we can then visualize the print better. We'll see all the ridges and all of the features a whole lot better than just looking at the superglue itself. Another fun chemical that we work with is iodine. So this one's called iodine fuming. And this is one of the oldest methods that we have for developing latent prints. This one is difficult to control in the sense that if you fume it for too long, the whole area changes color and you no longer can actually see specifics of your print. So iodine has the ability to sublimate, which means that it goes from a solid material straight into a gas without becoming a liquid first. So you put a little bit of iodine crystals in with your fingerprint. Normally the fingerprint is on some kind of porous material, and as the crystals sublimate, they react with the oils and some of the water and the sweat left behind on that print. It is going to turn that print purplish to yellow brown color. Like some sections will be purple, some sections might be more brownish or yellowish, but if you let it go for too long, this whole area becomes purple and you can't actually see any of the features. One of the downfalls to iodine fuming is the fact that this is not permanent. All of our other methods that we talked about, once you've done it, you have that print forever, or at least you can see what it visualizes forever. With iodine fuming, it goes away after a while. It'll start to fade. So one of the first things that we do once we've developed an iodine print, or we've developed a print using iodine, is we'll take a picture of it so that you have that record. This particular method works best if it's a porous type material, so paper really. Another popular chemical is crystal violet. Crystal violet is used for developing latent prints that are found on the sticky or the adhesive side of tape. So, you know, sometimes you pull tape off and it sticks to your finger. When you pull the tape off of your finger, you can see your print. Well, we can make that print stand out even more if we use crystal violet on it. So again, it's one of those liquid solutions that we just spray on. We give it a little bit of time and it turns your print it turns your print a bluish purplish color. Amido Black is another chemical that we would use. Specifically, it's a protein dye stain, and it works well for developing faint prints left behind in blood. So faint bloody fingerprints. This particular chemical will work really well to develop those. And it works equally well on porous surfaces as well as non-porous surfaces. So surfaces that can absorb stuff versus surfaces that don't absorb stuff. Another chemical is leucocrystal violet, also known as LCV. It's another protein stain that works well on faint or invisible bloody fingerprints, but this one really only works on non-porous surfaces, things that don't absorb liquids. Okay, so in more modern labs and as time progresses and technology improves, one of the things that we're doing more and more to visualize prints is to use lasers and to use alternative light sources. These were first used in the FBI in like 1978, in that time period. The only problem is you have to have lots and lots of training to be able to use these, and you have to take the safety precautions necessary, because especially the lasers can damage the retina of your eye to the point where it doesn't work anymore and you're now blind. Okay, so once we've developed the print, we then want to preserve it. So the primary means of preservation for a print would be to take a picture of it. Then we would cover the print to make sure that we have it in its entirety, especially if the print is on a small object, something we can leave the scene of the crime with. If the print is on a large object, so that we can't take the people's leather couch with us out of their home, then we would lift the print with adhesive tape. We would place that tape with the print on a card, and then we'd label it. So let's talk about what's in prints. We know it's a mixture of like water, fats, and oils, but let's talk about actual amounts. So the majority of your fingerprint is going to be sweat, and then the rest of it is going to be contaminants. In your sweat, anywhere between 99 to 99.5% of that sweat is actually water. And then the other 0.5 to 1% is going to be some kind of solid. Sometimes the solids are organic solids, organic meaning that they have carbon in them. So those would be like your proteins and your amino acids. And the other 50% would be inorganic solids like salt and HCl. The contaminants can be things like blood, saliva, secretions, bodily fluids, that type of thing. And then it can also be oils and fats, especially in the form of sebum. Okay, so the following are factors that affect fingerprints. So over time, as you get older, that will affect how much of a print you actually leave behind. It doesn't affect the pattern so much, like the physical pattern, but it does affect how much of the print you can leave behind. As you get older, your skin gets thinner, so that that affects it a little bit. And then you have a thinning out or a flattening of the dermal papillae, and the dermal papillae are the sections of your skin that control the shape or the pattern of your fingerprints. And then sometimes you add wrinkles and creases, and those things will shift the pattern just a little bit. Some people don't make as much contact with the surface as others, so those result in what's called a partial print, where we can only see a section of your fingerprint, or maybe we don't get an overall clear image of what your print is. Then there are certain stimuli that can either cause you to leave more effective prints or less effective prints. Maybe you're sweating because it's warm, or you on drugs, or you have a fever, or you're worried or anxious, or you've eaten certain foods that cause you to sweat more. The more you sweat, the more clear of a print you're going to leave behind. There are some medical conditions and some occupational conditions which can over time alter your prints. So if you work with lots of papers, or you work with your hands a lot, that can change some of your ridge structure. It can blur some of the ridge structure out, so we won't see some of those characteristics as clearly as we once did. Okay, continuing with factors that will affect the fingerprints, we have transposal factors. So that's stuff like what kind of surface are you touching and leaving your print behind. If it's a surface that has texture to it, so think like those popcorn ceilings or those walls that aren't smooth all the way, then that's going to change how much of your print we can actually see. What's actually on your hands? Some things leave better prints than others. Is there anything on the surface? Is there blood already on the surface, or oil already on the surface, or something like that? What type of contact was it? Did you mean to put your hand there, or did you accidentally put your hand there, or was your hand thrown there? That kind of thing. How much pressure? If you push a lot, you tend to leave a clearer print than if you lightly apply pressure to a surface. Then there are things like environmental factors, like temperature, humidity, and if anyone else has touched or disturbed that surface since you've left your print. Okay, the last thing is going to be trends with fingerprints. So unlike some of our other evidence, it is not possible to determine the age, sex, or race of an individual solely from their fingerprints. But there are some statistics and some other things that we can take into consideration. So generally speaking, the younger the person, the more detailed those prints tend to be, because you have better friction ridges. Also, the friction ridges on women tend to be just finer. They tend to be more skinny or more slender than the ridges left behind by men. Things that involve you using your hands a lot, or things that involve you being really strong in your hands, may cause your ridges to strengthen or to puff out a little bit more, so they will leave behind better prints. Keep in mind that women tend to perspire or to sweat less than men overall as a whole, so our prints aren't going to have as much sweat in them, and sweat makes up the majority of the print. Also, women tend to have lower levels of sodium chloride, so there's not going to be as much of that salt within our fingerprint. And creases are more common in women's fingerprints than they are in men's fingerprints. So we mentioned APHIS before when we talked about the history of fingerprints, but let's go through and talk about APHIS again. So APHIS stands for Automated Fingerprint Identification System, and it's a computer system for storing and retrieving fingerprints. It got fully computerized in the 1970s, so at that point we were able to search for large files for sets of prints. We were able to compare a single print, and by the 1990s, nearly every large police jurisdiction had their own system in place. The problem was everyone's APHIS had different prints. So the APHIS for Texas had prints that the APHIS for California didn't have, that the APHIS for New York City didn't have. So that was a bit of an issue. So in the 2000s, IAFIS came on board, and IAFIS is the FBI controlled integrated fingerprint identification system, and this is the national database for every single 10 print card, all over the country. So IAFIS has every single print that's American based, whereas AFIS just has local prints. Okay, so at this point, that's it. We're over with the notes. So from here on out, you are going to use these same notes. Go back to that slide that showed the minutiae or the ridge characteristics, and you are going to look at that packet that's labeled, ridge pattern or ridge characteristics packet or identification, something like that. So there are 8 different fingerprint patterns. You are going to choose 6 out of the 8. For each fingerprint, you are going to identify what large group it belongs to, so if it's an arch, a loop, or a whorl, and then you're going to tell me what subgroup it belongs to. So is it a plain arch or a tented arch? Is it a radial loop or an ulnar loop, etc., etc. And then you're going to find at least 7 different minutiae or characteristics on each print. If you need to use a magnifying glass, you guys know where those are, so go ahead and help yourselves. Just make sure you put them back. All right, I will see you next week. Take care. Bye.